Hey guys, today we're going to talk about the evidence that we have to prove that the earth rotates. Let's talk about it. So, the first evidence is the Coriolis effect. We've talked about this before. Because the earth rotates just like this merry-go-round, winds and ocean currents, even though they're trying to go straight, they kind of curve just like this ball. She's trying to throw this ball across to the other person, but it's curving around right back to her. And what happens is because of the Coriolis effect, winds and ocean currents tend to deflect towards the right side or clockwise in the northern hemisphere, and in the southern hemisphere, it kind of does the opposite. It goes towards the left side or counterclockwise. This is because of the way the Earth spins. It looks kind of different in the northern hemisphere versus the southern hemisphere. So let's write this down. One of the evidence for Earth rotation is the Coriolis effect. In the northern hemisphere, winds and ocean currents move clockwise because of the Coriolis effect, and in the southern hemisphere, winds and ocean currents move counterclockwise. So here's another evidence. Another evidence is the Foucault pendulum. It's a pendulum that Mr. Foucault here discovered. So what is this? Let's talk about a normal pendulum first. A pendulum is this little thing that swings along a string just back and forth. You might have seen one before. And a regular pendulum will normally, if you push it, it will just move back and forth, right? It won't make a crazy circular turns normally unless this area is unstable or you're holding it. But if you were just hanging it normally and you gave it like a little um, flicker, I guess, it would just move back and forth. But this guy Foucault discovered that if he created a pendulum that constantly moved back and forth and didn't stop, then what would happen is because the earth rotates, that pendulum instead of just going back and forth, it will start to make this kind of motion. Okay. And not because the pendulum itself is moving, it's because if the pendulum continues to move for that long, the earth will rotate just like this, right? So even if the pendulum is just moving back and forth, since the earth rotates, it will look like the pendulum is rotating, moving its direction in different ways. So in actuality, what is happening is the pendulum is swinging in the same exact direction, but the earth underneath is moving. And that's exactly what Foucault discovered. So the Foucault pendulum, a very special pendulum that just moves back and forth and doesn't stop. It proved the Earth's rotation because even though the pendulum is swinging in one direction, its path appears to change because the Earth underneath is actually rotating. Okay, so the pendulum is going this way, but eventually it will start to go this way because the Earth is moving and this way. So let's write this down and remember the spelling as well. One of the Earth's evidence for rotation, the other evidence is Foucault pendulum. What's our other evidence? The apparent daily path of the sun. So let's talk about a new vocabulary word, which is apparent path. You can write this down in your notebook if you need to. Apparent means it seems to be something, but it's not really. So if I'm talking about apparent path, the path seems to be it, but it's not really the path. So the path in which something seems to be moving, but is not really moving that way. So when we're talking about the apparent daily path of the sun, I'm saying that even though the sun looks like, if we took a time lapse of the sun in the sky throughout the day, it would look kind of like this. The sun appears to be moving up and then back down in like a rainbow style, right? But that's not actually what's happening. The sun actually isn't moving like this at all. It's the earth that's spinning that's causing the sun to move like this, or it's the apparent path of the sun, what it seems to be, but really isn't. Okay. And we've talked about this over here, right? Rotating as the earth is rotating, um, different parts of the earth will light up, right? Because of the sun. So those parts will start to see sunrise. And as those same parts are moving away from the sun, those parts will start to see the sun set. But really, the sun isn't really moving, right? Based on this video that we saw previously, the sun is staying still. It's the earth that's rotating. And that's why people on earth see it. It looks like that for us when we look up in the sky. And that's actually one of our evidences. The sun daily. The sun looks like it's setting and the sun looks like it's rising, but it's really not. It's the earth rotating. Let's write this down. Our third evidence for rotation is the daily apparent path of the sun. Apparent because the sun isn't actually taking that path. It looks like it because of the earth's rotation. Speaking of the sun, stars kind of do the same thing. So the parent path of the we said is the path that seems to be something seems to be moving in, but isn't really. And just like the sun, if you took a time lapse of the stars at night, they would look like this. They would look like they're moving like this. But really, what's happening is the earth's rotating, right? So even all the stars around the earth will look like they're moving um to us when we're looking up at the sky, but really the earth in which we're living is moving. And if you're someone standing up in the north pole and you look up, you'll see that even though all the stars look like they're moving like this, one star will stay still. And remember, the star is Polaris because Polaris is right above the north pole. So write this down. Our last evidence for rotation of the Earth is the daily apparent path of the stars. In the next video, we're going to talk about the evidence of Earth's revolution.